Alrighty, so we are just going to go right into our first problem. We have our velocity function that equals t squared minus 4t plus 3 on the interval from 0 to 5. And so with velocity, we're measuring speed in a direction. So the first thing that we're going to focus on is direction changes. So to find direction changes, we set the velocity function equal to 0, and we can factor t minus 3 times t minus 2, or sorry, t minus 1, solve, and then we'll get 1 and 3. And so that fits in our interval of 0 to 5. And so the reason why we want to find direction changes is it plays into our displacement, see where or how much direction our object that was traveling on this function traveled. And so to find direction changes, we'll split these off from 0 to 1, 1 to 3, 3 to 5. Pick numbers between those, and I picked 0.5, 2, and 4. You plug those numbers right back into the velocity function, and then you find out if it's positive or a negative number. And so by doing that, I got positive, negative, positive based on these results over here. And so we can also see that on the graph over here of the function, that when the function is crossing the x-axis at 1, it goes from positive to negative, and then when we're going back up, we're crossing the x-axis again at 3 from negative to positive, so we have two direction changes. And so that plays into our displacement because our displacement is working with the net change in position. Basically, the final position of the object that was traveling on this velocity function minus the initial position. And so that's why so this is our displacement equation. And so we're going to use the starting, which is 0, and then the final, which is 5, and we're going to take those and subtract each other. So we're going to put our function into an integral, and we're going to find the antiderivative. And so by doing that, we find it's t cubed divided by 3 minus 2t squared plus 3t. And so we plug in 5, and then we subtract that all by plugging 0 into the new function, and then we get 20 over 3 minus 0 equals 20 over 3. So that is our displacement. And so our displacement is a little bit different than total distance traveled. I have a graph over here, so if you see the function for total distance traveled, it's the same thing as displacement. However, we're taking the absolute value of this velocity function, because regardless if we have a negative or positive area or positive or negative distance traveled, we want to just know the total. But when it comes to a negative direction or a negative area, that is important when it comes to displacement, because we want to find the difference versus we just want the total distance traveled. So I have a graph over here kind of illustrating what we want. So we have 0 to 1, 1 to 3, 3 to 5. We want those little chunks of areas, and we're just going to add them all together to get the total. And so that also explains why we can have a displacement of 0, but you can have a distance, a total distance traveled equals 0, but that just means your object is just not moving on this function, or there's just no function. However, displacement can be 0 because, for example, I have just a mini example that it could look like if you go 2 units to the right, that's your starting, and then you go 2 units left, and that's your final. Well, you're right back to where you started in the first place, so you have a displacement of 0. 2 minus 2 equals 0. However, same thing if you have versus the total distance traveled, you just have no object moving on your function. There's no distance that has been traveled because it hasn't happened. And so doing the same thing, we have the same intervals that we have up here. Also, you can see on the graph to see that we want this area 1 plus 2 plus 3. We'll plug that back in to that function. That integral with that velocity function. And we're going to add those together. So we have 1 plugged in minus 0 plugged in, plus 3 to 1, plus 5 to 3. And again, we want to take the absolute value because we just want to know the total distance traveled, and we get a 28 over 3 also. There's some more work over here showing that be done. And yeah, that is our first question. Okay, so to move on to our second question, we are working with the function of y equals x squared minus 2, y equals x, and the x-axis, or y equals 0. And so first we're going to sketch it out. And so we want to find the region that we're trying to find the area of. And to find that, we're going to find whatever region that touches all three of these functions. And so you can see that y equals 0 and that y equals x and x squared minus 2 is this region right here, only the first quadrant. So I'm going to also to make sure that all of our numbers are positive as well, because we're working only in the first quadrant. And so moving on, we're going to find the intersection points. So to do that, in terms of x, we're just going to take our equations and set them up equal to each other. We find x can equal -1 or 2. However, we're only going to take the 2 because all the numbers are going to be positive since we're in the first quadrant, and also the origin, 0. So that is our range in terms of x from 0 to 2, versus dy in terms of y. We'll set, or first we're going to convert our functions that we have and set them in terms of y. And so to do so, x equals y equals x, same thing. However, we are going to take the other equation and find that it equals plus or minus square root of y plus 2. However, we are only working in the first quadrant, so we're going to take the positive square root y plus 2. And so also, to move on over here, this is me solving for what the range would be. And so taking those two functions that we solved in terms of y, setting them equal to each other, and finding that y equals 2 and 0. Same thing, it has a -1 as well, but we're only working in the first quadrant. So this range in terms of y is from 0 to 2 as well. So coming back up here, we're going to show why the terms of y is simpler, because if you can see over here, you can kind of tell based on what I drew, there's two regions that are required. So basically 2 integrals that would have to be set up and found and evaluated to find the area of this if we're taking it in terms of x, which uses vertical slices. And so that means that we would have to take this y equals x, integral of that, and then add it to another integral of same thing, this y equals x minus this x squared minus 2. And so that would just be a little bit more complicated. We're working with 2 integrals instead of 1. Versus if we do it in terms of y, which is horizontal slices, we are going to have the same function, because in terms of y, you can kind of, to find out which function goes on top or right, if you're looking at it from the x-axis, it's from right to left. However, if you're pretending like you're standing on the y-axis, you can still see which one's the top minus bottom. And so it's more clear that x squared minus 2 is on top and y equals squared is on bottom, and you only need one integral for that. And so we're going to so now we're going to find out and set up the integral in terms of y. And so just like I said, our right one is going to go on top, because it's right minus left. And so our right one is that x squared minus 2. However, we need to solve it for terms of y. So we already did that. That's the square root of y plus 2. So we're going to do the square root of y plus 2 minus y dy. And again, our range is from 0 to 2. And then this is me also doing the integral and the vertical slices I was talking about with the two integrals. And so to find out what this section is, because we are working from range of 0 to 2, the initial and the final, however we do have this number in the middle that we have to work with, because both of our two integrals are going to be ending or starting at this point. So to do that, we just take that x squared minus 2, set it up equal to 0, and so we get a plus or minus square root of 2, but again, we're only working with positive numbers because it's the first quadrant, so it's going to be the square root of 2. And so we have, just like I drew up here, where is it? There it is. Our first one is only going to be y equals x minus 0, or just x. And so and then our second one, our top one, is still y equals x, but our bottom one is going to be x squared minus 2. So we're going to put 0 to the square root of 2, x dx plus x minus x squared minus 2 dx, with the ranges from square root of 2 to 2. And that is if you do the vertical slices. And so to evaluate, this is lots of math right here, if you can see. But now we're just solving the integrals for the vertical slices. And we get a whopping 10 minus 4 square root of 2, all divided by 3. And then, yes, just to have it more clear from all that math. And yeah, so that is our second question. We're going to move on to the third question. We have some new functions. We are working with f of x equals square root of x plus 1, and g of x equals x squared plus 1 on the interval from 0 to 1. And we're revolving it around x equals 2. And so I'm just going to go ahead and show my graph that I sketched for this. And we have this region because we want it to be between f of x and g of x. And so this is the region that it cuts off to, and we have those two intersection points, which one of them, or first we have our range in terms of x, which is 0 to 1, because that's the range that we were given. However, in terms of y, we'll find that out later, but one of those is y equals 1. But where they meet at that second intersection, whatever y that is, we'll find that later. However, I drew it over here, what it looks like revolved, but also that there's a gap. So that function does not intersect at where x equals 2. And so we'll have to take the difference of that because we have that gap. And so this is me finding the intersection points. Like I said, we have the dx is already 0 to 1. But dy, first we have to take the f of x and g of x, and we have to put it in terms of y. So we solve and we get, for f of x, it's y minus 1 squared. And then for our g of x, we get plus or minus square root of y minus 1. But we're only in the first quadrant still, so it's going to be positive only, so it's going to be square root of y minus 1. And so to find the range